We'll now move on to identity operators. There is an identity operator is, and there's also an identity operator is not. These are subtly different from comparison operators, which we've previously looked at, in that the identity operators are comparing variables' locations in memory instead of their actual values. So I'll now talk you through identity operators, which are is and is not. So again, we set A equals 8 to 10, and then we set B equal to A. We have C, which is A is B. What this is doing is checking, does A point to the same object? Because in Python, everything is treated like an object. We'll be covering this in a later lesson, and it's saying, this check here, this operator is applying, is this object the same as this object? Here, A is assigned to B, so it's pointing to the same object. So if I was to print this out, the response would be true. Again, it's a Boolean result. You could say, for example, you set B equal to 20. Here, this will be pointed to a different object in memory. So this will return false. You can prove this. There's a function ID which tells you where the variable is in memory. So if I was to print the following, this will make it clear what's going on. So what we see here is applying the ID function tells you its memory location as follows. But when you check the ID location of B, it is different. So when we're doing this, assigning C, A is B, the answer is false because it points to different areas in memory. Say, for example, A had been changed to 20. Now you can see A and B are in the same location in memory. Because the way Python works is with a number, with objects, there will only be one instance of 20 in memory. There wouldn't be different instances of 20 in memory. And you get true as a response. Is not, it's just checking that they're not the same, pointing to the same objects. So for example, if we was to run this, you get the answer is false because they are the same object. So this is saying, checking, is A not the same object as B? It is the same object, so the response is false. If we was to change it to 21, you can see the memory locations have changed, so therefore the response is true. Identity operators can be applied to all the types within Python, such as float, integer, as we've just seen, Boolean, strings. Here is an example with two string variables, A, which has been assigned the value test, B, which has been assigned the value test, and C, which has been assigned A is B. And then we print out C. And then just for your interest, I've also printed out the equality between A and B. So when we run this, you see the result true. So what this is saying is the variable A, which points to test, and B, which points to test, are pointing to the same value in memory. So test is stored in the same location in memory, and A points to it and B points to it. This is the way Python stores its values. There will only be one value of test, and this will be shared between these two variables. And so when A is checked by the identity operator is against B, the result is true when we print it out. The equality operator is subtly different in that A's value test is being checked against B's value, which is also test. So it was really checking the values here with the equality operator, where the A is B is checking the locations in memory, with A pointing to the same location in memory and B is pointing to the same location in memory. It is possible for two objects, with which variables point to have the same value, and in such a situation, the equality operator will return true, but the actual the objects themselves are stored in two different locations in memory with the same values. but we'll cover this at a later stage when we're creating our own classes and also when we're discussing things such as lists. In the next lesson, we'll move on to if statements.